Hello, today we'll talk about shortest path and we'll answer these questions. Dijkstra's algorithm is an algorithm that allows us to find the shortest path between any vertex of a graph. Let's say you need to find the shortest way from home to the university, to the market and to the bus station. The blue number next to each edge is the weight of the corresponding edge. The distance from the source node to all nodes that has not yet been determined, so we use the infinity symbol. Since we choose the start from a node, we will mark this node as visited and delete it from the list of unvisited nodes and add a red frame to corresponding node. Here we check the neighboring nodes and add the weight of edge for first 5 and for the second node 8, and then select the closed node. Mark it as visited and add it to the path. We need to update the distance from the source node to new adjacent node, node 3, which is equal to 7. Now that we have the distance to the adjacent nodes, we have to choose which side will be added to the path. We must select the unvisited node 0, 1, 2 and compare with the previous value of node 2, 8 or 14, which is shorter path. Of course 8, and we add it to the path. Only one node has not been visited yet, node 3. Let's see how we can include it in the path. Option 1, 0, 1, 3, which is distance of 7. Option 2, 0, 2, 3, which is distance of 13. We select the shortest path 0, 1, 3 with a distance of 7. We mark the node as visited and cross it off from the list of unvisited nodes. And voila, we have a final result with shortest path from node 0 to each node in a graph. It's also used in IP routing to find open shortest path first. When the source and destination is known, the robots move in an ordered direction by following the shortest path to keep delivering in a package in a minimum amount of time. Engineers can imagine a city as a network and identify the best place to build roads and to place irrigation pipes to distribute water to the population. About pros and cons, one of the main advantages of its little complexity, which is almost linear. It can be used to calculate the shortest path between a single node to all another nodes. It only works for directed. Weight directed and all edges should have non-negative values. Is there an alternative? Yeah, Bellman Ford, but tends to be slower than either Dijkstra's. Now let's look at the implementation of Dijkstra's algorithm, which finds the shortest path from the node 0 to each node of the graph. Here we find the minimum distance and add our graph to a two-dimensional array and run our code. As you can see, the answers match our calculations. So I think it was interesting. Thank you for your attention.